All right, how would you solve 4x equals 12? You would divide by 4 on both sides and find that x equals 3. 4 and x are blank, while 12 is the blank. X can be thought of as a blank blank. This is the same concept used to find missing factors. 4 and x are factors, while 12 is the product. X can be thought of as the unknown value. And then we know this concept as missing factors. All right, so let's apply this to our first problem. We have 6a squared times some unknown value equals 24a to the 5th m to the 9th. The easiest way to do this is to match it up term by term in the monomial. So from 6 to 24, what do I need? Well, I know I need to multiply it by 4. To go from a squared to a to the 5th, I know that I need to multiply by a to the 3rd because I need 3 more a's to get from 2 to 5. And to go from m to the 9th, I know I need 8 more m's, so I need m to the 8th. Then I'm going to put all 3 of those together and I get 4a to the 3rd, m to the 8th. And that's our first method for solving. We also have a secondary method. We can use our second method is actually using division. And that's going to be using the same strategies that we learned earlier this week on Monday and Tuesday. So I'm going to take 24a to the 5th, m to the 9th, and I'm going to divide that by 6a to the 2nd times m. And remember, our rule is when we're dividing monomials, we divide our coefficients and we subtract our exponents. So 24 divided by 6 is 4. So we end up with 4a to the 3rd and m to the 8th because we subtract 5 minus 2 and then 9 minus 1. All right, we have our next example, negative 25x to the 4th, y to the 6th equals 5x to the 3rd times y times some unknown value. Again, we're going to go with our rules. We need to know what number times 5 gives me negative 25. And I know that that's negative 5. Then I have to ask myself what number times x to the 3rd will give me x to the 4th. And I need one more x, so just times x. And then I ask myself, I have y and I need to get y to the 6th. So what do I need to multiply by? Well, I know I need to multiply by y to the 5th because I need 5 more y's. I put all of those together and I get negative 5x y to the 5th. All right, now we have our next example. Actually has 3 terms involved where that we have 2 and then we multiply by a 3rd term to find our solution. So the easiest thing to do is to multiply your first 2 terms that you know together and then figure out what you need to go from there to your solution. So if I do that, I'm going to end up with negative 15 r to the 3rd, s to the 2nd. And then I have to ask myself, how do I get from there to my solution of 45 r to the 6th, s to the 4th? Well, to go from negative 15 to 45, I know I need to multiply by a negative 3. To go from r to the 3rd to r to the 6th, I need 3 more r's, that's r cubed. And to go from s to the 2nd to s to the 4th, I need 2 more s's, so that's s squared. And you put all those together and you get negative 3r to the 3rd s squared. We're skipping example 4 and using that as a try it on your own, and we're going to move on to greatest common factor. All right, a greatest common factor is the blank term that blank evenly into a set of terms. It is the largest term that divides evenly into a set of terms. So that's your greatest common factor. And you did this a long time ago when you were in probably 5th, 6th grade when you were first learning how to multiply and divide. So this is going to be the biggest number that I can take out. So the biggest number that I can take out of x to the 5th and x to the 3rd is going to be x to the 2nd, or it's going to be x to the 3rd, because x to the third has 3 x's and x to the fifth has 3 x's that I can take out. And there'll be some leftovers, and that's okay. You're just looking at the biggest number that you can possibly take out, leaving behind any leftovers. All right, next example. We have x squared, y to the third, and x to the sixth, y squared. We're going to factor those out. That's the fastest and easiest way to do this. So we got 2 x's and 3 y's, and then we have 5 x's and 2 y's. We're not going to write this as a division problem or a multiplication problem, just making a list. And once you've made your list, we're going to circle what's in common in both groups. Instead of eliminating what's in common, we're actually circling them. So both groups have 2 x's and 2 y's in common. So our greatest common factor, or the greatest number that can be multiplied by either of these monomials, would be x squared, y squared. All right, you are now going to try number 7 and number 8 on your own. So use this time to give number 7 and number 8 a try. Find the greatest common factor. What can you take out of both of them? You are now working. You are not staring at the screen. You are working. You are attempting this problem. Stop staring at the screen. Do not look at what I'm drawing. You are working. Do, 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 do. All right, answer to number 7 is 4m squared, and number 8 is 8c squared. The d's don't factor out and the e's don't factor out. All right, let's do our last example. This time we have 3 terms. In this case, I'm going to use expanded notation because it's a lot easier to find all my factors. But I'm doing it kind of in a modified fashion. So here are my prime factors of each of my coefficients. I have 3, 2, 2, I have 7, 2, 2, and I have 5, 3. And then I'm going to look at my each of my variables separately. What's the least number typically is what you want to look at. The greatest common factor is really going to be equal to your smallest one, because the greatest number you can take out of the lowest possible term you have is equal to that. So my x's, that's going to be x to the second. For my y's, that's going to be y to the second. And then I'm going to be able to take out 1z. All right, with my variables, I'm able to take out x squared, y squared, z, because that was the biggest number that was in all 3 groups. But I cannot take out any whole numbers or any coefficients, because although the first 2 groups both have 2's in common, and the first and the last term have 3's in common, there's no number that's in common with all 3 groups. So there's no factor coefficient that I can factor out. So my greatest common factor is going to be x squared, y squared, z.